Hey everyone! So today, on our final lesson of this section, we are going to be combining some of the aspects which we have already learned in our first two lessons with gravity and friction to help us understand dynamics, or a better term to understand that, and more simplified, we will talk about velocity. And then from there we'll talk about acceleration, our displacement, and our change in time. So, bear with me. We're about to go outside. It's a little wet, but that's going to help us look at two different scenarios. I will be riding my longboard. First, we will be doing it in the parking garage, hopefully where it's relatively dry. So then we can look at myself when I'm longboarding, and then myself with my book bag, which is right here, which I will be filling with as many books as possible that I will be able to hopefully carry without falling, to show change in speed and acceleration with different masses. As I am not going to be able to easily change my mass, I'll just put on a book bag and add more. And then secondly, we will be going to the top of the parking deck, where right now it is raining fairly well, and look at how that difference in environment will be changing our friction. So we know before we were talking about friction occurs everywhere. So this is going to be a good example to see the two different scenarios. We will have friction on a dry surface and then friction on a wet surface. Very wet as well, because it's been raining for the past 2 days. So hopefully we'll be able to see a clear distinction in our experiments. So see you out there. Right now, as you can see, it is very wet outside. It's been raining non-stop for the past couple days, so it should make this experiment rather interesting. So as we walk over, I also realize I have another technological marvel to help me with, is my iPhone. And my iPhone, the iPhone 5, actually has a slow-mo video option, which is going to be able to help us slow down and be able to look at exactly what it is that we're doing in a fine-tuned sense. So I can't wait to see you up there. Everybody, so here are my brief notes on the information that we will be learning today in the field. So right here we have our first equation, and I've written down on this side, better way to see what's happening. So this is our very simple velocity equation. So we have v is the velocity, which is your final velocity, which you're at the end of whichever time frame you're looking at, that is a velocity that you're looking for. VO, or V naught, is your initial velocity. So in our situation, V naught can either be 0 if starting at rest, or if you were to choose a point somewhere mid-run when I'm doing my longboarding, we could use that as our initial velocity. But let's assume that our initial velocity is 0. And then A is our acceleration, which on this surface might not be as important because we're going to be trying to maintain an acceleration of 0, just for simplicity's sake. And then delta T is our change in time. And then if you look down at the rest of these equations, you can see how they're all very interconnected. The second one, you find your average velocity by taking more or less the average of your final and initial velocities. And then if you wish to find your displacement, you can use this one right here. So you have your final position, which is x, is equal to your initial position plus the product of your change in time times your initial velocity plus your acceleration times the square of your change in time over 2. And that will give you your final position. And then down here is also a fourth equation that we can use to find certain variables that we may not be able to take out from these. So this is a good equation for delta x, or x minus x initial, which is saying right here we have x initial, But say we're looking for our velocity and we don't have time, but we have acceleration, final velocities, or initial velocities, but we're only missing one variable. This is a great equation to use, or any of them, regarding whichever variable it is that is missing from your given information. So I'm going to get out, set up the tripod, and see what we can get done today. Alrighty. Alright, so we're going to be looking at two different scenarios right now. First, this is relatively dry, drier than when I'll be going up to the top floor. And we have our longboard, which the wheels are pretty dry right now, so that should be giving it a dry friction surface. And I'm just going to go from over to here to there and give us a quick view of me as my mass with one or two pushes just to look at the velocity that I got going. Relatively quick. You know, the wheels are getting a little bit slicker now because it's a little wet down here. But moving pretty quickly on a horizontal surface. Now I'm going to take my book bag, and with my book bag I'm going to have much more mass. I have 3 relatively big textbooks in here, so let's see what happens. If anything, it'll be a great shot of a blooper. As you can see coming in, we'll probably slow this down. You can see that with the book bag, I'm moving slow because I have a flat surface. I need to do more work, put out more energy to get myself going, and I'm not going as fast because I have no source of acceleration. I'm pretty much just on this flat horizontal surface, going until I stop. Same thing as without the book bag. I was going faster because it required less energy for me to push. So pushing at the same output energy was allowing me to get going faster and increase my velocity. And also because there's no friction, we're able to go faster. So now I'm going to move on up to the top floor. Gonna get a little wet, but hopefully you're good to go. Alright, so I decided not to go all the way upstairs, but instead I decided I'm going to use this ramp. It's very wet. It comes down to this awesome waterfall, and I'm going to do a few runs from there in order to show you a few things. Now we have friction with a liquid, which is going to slow me down a little bit at first, but then we'll see what happens. Also, now that we have an inclined plane, gravity and the inclined plane itself are going to help accelerate me, and I will be going without the book bag first, see if I survive that way. Then I will try zoot the way with the book bag. So hopefully, if I do fall here, I'm alright. If not, it'll be a great blooper. So I'm going to go start a second video. I'm going to use the slow-mo function, try and see change in speed. And I'm going to go run up there and hopefully not kill myself on the way down. tentative there to try that after the first run, but as physics is always right, it proves me wrong because the friction of the water slowed me down a lot because I had to raise the mass. More weight on top of that with the water, even though it was an inclined plane and it was gravity helped me out coming down, still slowed it down enough to where I was up at the top freaking out, and then next thing I know, coming down here, relatively simple, very easy turn, wasn't going too fast, so physics prevailed. So I hope you enjoyed it, but we'll be continuing with our next few topics from here, and then we go from this episode. I think those guys were a little weirded out. Something must have been going on up there, but I'm just doing physics. You don't hear or see it from me. This is my last word. But as we saw with our equations earlier, they don't take into account for the angles of the parking garage. They don't take into account for friction. But they are the very simplistic formulas which will yield velocity, displacement, changing time, acceleration. So, as you saw earlier when I was doing the horizontal, that was a rather simple experiment, more or less, because there's no acceleration, no incline, gravity wasn't helping me down, and it was dry. And then in a situation where everything came into play, we saw that with a lesser mass, and a wet surface, incline, gravity, the lesser mass went faster because there was not as much mass to contact with the frictional force of the water, thus allowing me to go faster without the go fast. So I hope you enjoyed our final video of this session, and if you have any questions, any comments, if you want to see me try it with a steeper slope, with a maybe even an incline upwards, so where I would be going up against the steepness of the slope, or anything, trying to do it in the snow. I know it's April now, but next year, once that winter weather comes rolling around again. But until then, comments, questions, I can do it better, leave them all in the comments below. Follow Instagram, Twitter, and keep us posted with all your physics questions, and we'll do our best to help you out with answering them. Thank you.